All right, we are supposed to be doing, we were actually doing metals. In metals, we have already discussed the difference between the chemical and physical properties of metals and non-metals. We have already discussed the properties, the characteristics of metals, and we have already discussed that why we need alloys, why are metal, why are metals not really suitable for our industrial and daily use, right? And that is why we need to we need to mix them with other elements that can be metals and non-metals, but it is a mixture, it's not a chemical bonding, to form alloys. And then alloys help us in our daily and industrial use generally, due to their enhanced characteristics, physical and chemical both. All right, so we were doing metals. Now metals, we have to study the reactivity series. The reactivity series. Reactivity series, in this we just have to understand there is a set of uh, there is a series of metals which which can be referred to, and which helps us understand the order of reactivity of each metal. All right, which metal is more reactive, which metal is less reactive. There are few common metals that we generally use in our industrially, and in the laboratories. So we are going to be discussing only those metals which are generally and commonly used. All right, we are not going to be discussing the reactivity of all the metals. You can find that on internet, the chart which tells you the order of increasing reactivity and all of that. But we are only, what we are going to be discussing in our lecture is going to be only what generally is required for us to know, the order for the elements that we are required to know. Generally, the order of reactivity basically is in this manner. We say that the potassium is more reactive than sodium, calcium, magnesium, aluminum, then we have zinc, then we have iron, then we have after iron we have Pb, which is lead, then we have copper, and in between there is hydrogen as well. We'll discuss that later words. But copper, then there is Hg, mercury, then we have Ag and Au. This is the reactivity series that generally we need to we have to keep in our mind. This order of reactivity. So the reactivity generally, this is in decreasing order. All right, this is an order of decreasing, decreasing downwards. All right, so potassium being most reactive in this series. All right, in this series, that the one that we have written, the most reactive, and Au, or silver, sorry, gold being least reactive in this series. All right, there could be more elements in between, there could be more elements at the top, at the bottom, but we have, this is a general rule that we have to, these are the general and most used and most studied elements. That is why we have already selected those metals. All right, all of them are metals. All right, except hydrogen. We'll discuss hydrogen later words, but we have to keep this reactivity in our mind. It needs to be memorized. You need to know the order of reactivity. All right, so what do we mean by that generally? What do we mean by the most reactive? It means potassium, the potassium has or is the most metallic characteristic. All right, this is what it means. Most reactive means has or is the most has the most, let's make rephrase this, has the most reactive, the most metallic characteristic, has the most metallic characteristic. What does that mean? It means that in order of giving an electron, or in order of reacting, or in order of uh, being a reducing agent, potassium is the most potent. The most potent reducing agent in all of those that are written is the most gives the electron very readily, is the fastest and the quickest to give an electron, lose an electron, right? This means that it is fastest to lose electron, best reducing agent, and least acceptance for electron, least to gain electron. All right, if any metals, they do not really accept electrons generally. If all of these elements were there, potassium would have been the last to accept electron. This is what it means. Do you understand? Anishba, do you understand? If all of these
जी
elements were present in a solution, potassium would be the last one to accept electron. Why? Because it is not meant to accept electron, it is meant to give off electrons, right? Is this,
जी
are you able to understand this? All right. So this
yes
is the reactivity. This is the reactivity, and it could be understood. This is gold. Gold is at the last, and gold is the least reactive. That is why we see that the jewelry made out of gold is very less likely that it causes anybody a reaction on his skin or something, because it is least reactive. All right. So let's come back to the reactivity series. This is the most reactive and the least reactive. The least reactive, the most reactive. This reactivity series needs to be memorized. All right. How do we determine? How do we determine? Hmm, how do we determine the metal? How, the question over here is, how do we determine the reactivity of metals? Basically, there are three methods. Reactivity of metals is determined by looking at how they react with, number one, water, which is also called cold water, then steam, and the third one is the hydrochloric acid. All right. We look at metals, how they react with water, steam, and hydrochloric acid. All of these metals that we have mentioned would have been reacted by the scientists with water, and they tried to analyze which one of them are reacting with water, simple water. The cold water means water which is at room temperature. And they were able to see that few of them do not react with water. So they said that they are not that reactive. The ones that are reacting with water at room temperature, it means they are more reactive. And the ones that are not reacting with water at room temperature, or reacting very slowly, not vigorously or rapidly or violently, means they are less reactive. Then they tried all of those which did not reacted with water with the steam. Some of them they reacted with steam, and some of them they did not reacted with steam. All right, the ones that were reacting with steam were less reactive than those which were reacting with water. All right, and then their reaction with hydrochloric acid, all of them were reacted with hydrochloric acid, and it was seen that which metal, we have already studied acids, right? In an acid reaction, if you could recall, we used to say, let's say zinc reacts with hydrochloric acid and it gives you what? It displaces hydrogen. Hydrogen becomes a gas
Gives zinc chloride.
and it becomes zinc chloride. Very good. It becomes zinc chloride, which is aqueous. This is aqueous, this is was solid, and this is gas. So it has, what has actually happened, zinc has displaced hydrogen and hydrogen had to go off. Let's, if you balance this out, so hydrogen had to go off as gas and zinc took its place. This is what actually happens. Another way to determine, another way to tell which is more reactive is by displacement reaction. The more reactive, the more reactive metals displace less reactive metals in a solution. You see, if you come here, I just want you to look at it. If you come here, zinc is higher than iron, lead, and even hydrogen. So that is why zinc is actually able to remove hydrogen from its solution. Do you get it? Even though hydrogen is not a metal, we're just discussing it. But if you look at Ag, Ag will not be able to react with acid. Why? Because it is lower in reactivity than hydrogen. It is less reactive than hydrogen. Only more reactive metals can displace the less reactive metals in a solution. Do you understand this point? We have not got to displacement reaction yet. We'll talk about,
Yes.
but I just want you to understand, because we have already done acids, so we should have this idea. All right, so you can write the fourth one as well by looking at the reactive displacement reaction. If a metal is displacing another metal in a reaction, it means it is more reactive. All right, is this clear up to now?
Yes. Yes.
All right, so we will get into each reaction one by one. So the reaction of metals with water, all right, a reaction of metals with water. All right, this means cold water. Whenever there's water, it means cold water or water which is at room temperature. You get it? So what happens? So basically, generally, what actually takes place? A metal that reacts with water, this is a general product that forms metal hydroxide excuse me, and hydrogen gas. Metal hydroxide and hydrogen gas. How is this performed? Basically, all right. Basically, the reaction starts in this manner. This is generally done in this manner. A beaker is filled with water. All right. Some mass of a metal is placed and a funnel is placed over it vertically. A funnel is placed over it vertically. And over that, a test tube is placed. All right. For the metals that react with water, for the metals, like let's say copper. Copper reacts with water, reacts with, sorry, not copper, copper is calcium. Calcium, let's say, reacts with water. Calcium reacts with water. This is water, right? H2O. This is calcium. So calcium reacts with water, and we see that this place, this region stays empty because of the hydrogen gas that is being deposited over here. Why? This bubble of hydrogen gas that is going to move up, and they are going to accumulate over here. Similarly, if you take a metal which does not react with water, you make a similar apparatus for it. You make a similar apparatus for it. Let's take water in this manner. And you place, let's say, zinc, and zinc does not react with water. It does not react with water. So you are going to see that the water will move up as well, because it is not reacting. No hydrogen gas is being given off. So the water moves up the funnel. Do you understand this aspect? Up the test tube. Understand? Is this clear? Have you made that? All right. So all right. So this is how these reactions are going to take place. So let's write for each of these metals. Okay. Let's talk about the. I'm going to summarize them, inshallah, as well, but I would want to give some detailed understanding and explanation, because you're going to get a lot of questions from this in your exam. So let's talk about the first one, the potassium. So you have to keep this set in mind. Potassium, I'm going to summarize them for now, and then we will go into detail. So just keep that in mind. Potassium, sodium, and calcium is the first set. This set, they react with water. All right. They react with cold water, which is water at room temperature, in which the first two they react explosively, react explosively, and calcium reacts violently. All right. Or readily, reacts readily. Rather, I would want to say that the best way, both of them they react, the sodium and potassium, both of them they react explosively. But for potassium reacts the very violently. Then sodium reacts violently, and this reacts readily. All right. These are the terms that we have to get accustomed to. So the most reactive way to react is very violently, then readily. All right. Then the magnesium is also able to react with water. It also reacts with cold water, but but very slowly. All of these things need to be kept in mind. Okay. Magnesium can fall under reacting with cold water as well, but it reacts very slowly, very slowly. All right. For others, there is no reaction. For others, zinc, iron, all of that, they do not react. Okay. All right. For zinc, iron, lead, copper, silver Ag, Au, sorry, Au, no reaction. They do not react with, no reaction with cold water. Okay. Then the next group is the ones that react with steam. The next group is magnesium, aluminium, zinc, iron, only if it is red hot or very heated, and Pb. They are the ones, basically you can say these four are the ones that readily they react with steam. But both the condition that is there, we're going to write them inshallah. All of them should be hot. All right, it should be hot. And then the third group is the group which is below hydrogen. Remember in the reactivity series, the one which was below hydrogen, I just pointed that out, which is copper, Hg, Ag, and Au. Copper, mercury, gold, and silver, they no reaction with water. No reaction with water or steam. Or steam. Even if they are hot. Why? You see, now they are below hydrogen. In order for them to react with water, they need to displace hydrogen, right? They need to do that, but they are not able to do it. Why? They cannot do that because they are below in reactivity than hydrogen. So they cannot displace. In order to displace hydrogen, they should be more reactive than hydrogen, right? So they cannot do that. They cannot. Is this clear? Is it making sense?
Yes.
Hmm. As for lead, it is very slow. The reaction with the steam is very slow, very slow. You get it? Let's write them. Let's write about them in detail, okay? Let's write about them in detail. There's some detail that you need to know that's going to be there in your assessment as well. So, potassium, when we talk about potassium, it reacts with cold water. It reacts with a violently reacts very violently. All right, and burns violently. It produces enough heat to it produces enough heat to burn hydrogen gas, with lilac flame. So in short, it reacts very violently with a lilac flame. You understand? So whenever you're going to, whenever hydrogen, if hydrogen is placed in water, if it is dropped, a drop of potassium is thrown in water, you will see that there's going to be a lot of smoke and there's going to be a flame, and that flame is going to be of purple color, right? Generally, it is considered that potassium is burning with a purple flame, but actually it is that it produces so much heat that the hydrogen gas that is being produced, right? The hydrogen gas that is being produced, it burns with this purple flame. It catches fire, all right? So the reaction is like this: potassium plus 2H2O, that is going to be 2 potassium hydroxide plus hydrogen gas. So it is this hydrogen gas catches catches fire and burns with lilac or purple flame. You understand?
Gcse.
The next is sodium. Sodium very violently needs to be memorized. You need to memorize. All right. So it reacts with cold water, reacts with cold water, number one. Secondly, it reacts violently. Hydrogen gas produced burns with or catches fire slash burns with yellow flame. All right. So the reaction is going to be like this: sodium, 2 sodium plus 2H2O is going to give you 2NaOH plus hydrogen gas. And this hydrogen gas burns with yellow flame. So in general, what is said? What is said? That it is said that sodium reacts with cold water violently with yellow flame. This is what is said. You understand? Is this clear?
Gcse.
The equations are very important. They need to be memorized. Okay. This is solid, then this is going to be liquid, aqueous, and gas. They need to be memorized. You need to write them. Then we have calcium. Obviously, calcium is less reactive than the above two. So it reacts with water, cold water, readily. Readily. Readily means fast. Bubbles. You can see a lot of bubbles. You can see a lot of heat coming off. Okay. You know, when you put sodium, the water actually becomes warm because this is a exothermic reaction, right? These are exothermic reactions. Metals, they react with water Metal with water reaction is an exothermic. Readily to form to form calcium hydroxide and no flame. No flame. Okay. For all of these three reactions, the one of the observation is the color, and the other observation for all of them is bubbles or effervescence, right? Bubbles or effervescence. And for here, it's only bubbles of hydrogen gas, right? And then you can do the hydrogen gas test, which is called squeaky pop test. We'll talk about it, inshallah. Squeaky pop test. So the calcium, and the equation is going to be calcium plus 2H2O is going to give you calcium hydroxide plus hydrogen gas, right? For all of this observation, for all, whenever hydrogen gas is produced, you know how to test hydrogen gas. A burning splinter, right? We were able to do that, I think, when we were doing metals. Can you recall? When we were doing acids, bases, and salts. In salts, you're going to find this topic in salts at the end. The test for different gases. So hydrogen gas is basically colorless and odorless, right? So a lighted